Okay, this question is paper 2, so calculators are allowed. Let's read the question together. A forest has a large number of tall trees. The height of the trees are normally distributed. Okay, so the distribution is given that it's a normal distribution with a mean of 53 meters. Okay, let's write it down. With mean equals to 53. So let's write mean. Okay. And standard deviation of 8. Trees are classified as giant trees if they are more than 60 meters tall. Okay, they are specifying one thing, that if the height of the trees is more than 60 meters, you will call that tree as a giant tree. So what it's saying that actually that if your tree is actually giant when the height of the tree is greater than 60 meters. Okay, this information is given. Now let's see. Part A. A tree is selected at random from a forest. Find the probability that this tree is a giant. Okay. A1. Okay. The probability that this tree is a giant, actually we need to calculate this particular probability since the distribution is normal. Just take out your graphical calculators. Go to the distributions. It's over here. I'll just go to the distribution and I'll use the normal CDF. And why I'm using normal CDF? See the question. Normal because it was given that it's a normal distribution. Why CDF? Whenever you have a sign of greater than or less than, or greater than equals to, or less than equals to, you always use CDF. So basically, normal CDF is used when you have two limits with you. Okay? Whereas when we talk about normal PDF, PDF is when there is a sign equals to over here. Okay? If it was h is equals to 60, that I have a giant tree when h is equals to 60, then I will use normal PDF. But right now, the question is telling me that my trees are giant when the height of my trees is greater than 60. So, I will use normal CDF. I'll go to normal CDF. Okay, for you, I think it's when you'll click stats over there, down here, there will be a list of like distribution, calculation and everything. You click on distribution. Again, you will find a list, norm CDF, norm PDF, binom CDF, binom. So in that, just click on normal CDF. 2. Okay, what will be the lower limit? The lower limit will be because h is greater than 60. So this is my lower limit, 60. And what will be my upper limit? Upper limit is actually not given, that till this height you will call it giant. It's like any big value. So whenever I use like graphical calculators, I always input the value 999 because it's a big number and it gives a very accurate result also. So I use this number. No specification. You can use 998 also. It's not like a hard and fast rule. Just take any big number. Okay, the mean is given, it is 53. And standard deviation is also given, it's 8. So let me calculate. This is my probability of giant tree. If I select any one tree at random, so this is my probability that my tree will be a giant tree. So my probability of giant tree is equals to 0.1907, or you can say it is 0.191. Okay, now let's see the part B. Okay, second part. Given that, it's a conditional probability, okay, because given that is there. Given that this tree is a giant, okay, what is given? That it's a giant. So let's start writing the conditional probability formula. What is given? It is giant. Find the probability that it is taller than 70 meters. One thing is given. So one thing is given that that your tree is actually giant, and then they are asking you that if it's a giant tree, what is the probability that the height is greater than 70 meters? To declare a tree giant, it was like my height should be greater than 60. But right now I'm interested in the trees, that if I'm taking a giant from trees from a giant tree, what is the probability that its height is greater than 70? Okay, so you can write it as probability of x greater than 70 over probability of g. Probability of g you just calculated in the last part, 0.191. Let's calculate the probability of x greater than 70. I'll do the steps again. You guys also go to the distribution. Okay, again it's a greater sign over here. So I'll use my normal CDF. Okay. Now my lower limit is changed to 70 because now my x is greater than 70. So my lower limit is changed and now it's 70. Whereas my upper limit, okay, it's a big number, fine. My mean and standard deviation is not changed, so I'll keep it as it is. Enter. So the probability that it will be like it's greater than 70, the height is greater than 70 is 0.1679. Okay. Now I'll divide these. I'll get 0.0880. So the probability that my x is greater than 70, given that it was a giant tree, is 0.0880. Okay, now let's move to part B. Okay. Part B says, 2 trees are selected at random. Find the probability that they are both giants. Both giants. What is the probability of one giant tree? 0.191, right? So what will be the probability of having 2 giant trees? So probability of both giants will be equals to probability of giant multiplied by probability of giant, which is equals to 0.191 multiplied by 0.191. If it was like 3 giant trees, so you will have 0.191 multiplied by 0.191 multiplied by 0.191, or you can say 0.191 whole cube. But right now they are asking for 2 trees that taken out and it's giant, so 0.191 whole square you can also write. Answer to this will be equals to 0.0364. So this is your probability that your both are giant. Okay, now let's do part C. Hundred trees are selected at random. Okay. Find the expected number of these trees that are giants. Okay. 100 trees are selected. Expected number you need to calculate of giant trees. Find the expected number of these trees that are giant. What is the probability of giant trees? Probability of giant trees we calculated is 0.191. Okay. What is the formula of expectation? Whether it's expected value or expected number for normal distribution, or whether it's for binomial distribution, it's the same. It's NP. Okay. N is the total number of selections, whereas P is the probability of that particular thing that is asked. So right now it's 100 trees. So N is basically 100, whereas they are telling you that it's a giant tree. So you will use the probability of giant tree. N multiplied by P. So the expected number is equals to 100 multiplied by P, which is 0.191. It is actually equals to 19.1. C1. Now let's see C2. Find the probability that at least 25 of these trees are giant. A very good catch in this question. In any question where normal distribution, they are telling you that this distribution is a normal distribution. And in that particular question, a part comes with at least or at most, like lines like this. And the number of selection is actually not really big. It's a fixed number. It's not till infinite. You have a fixed number. So in that particular case, you use binomial distribution. I'll repeat. Whenever you have a question and they are telling you that this is a normal distribution which is given, and then in one part they ask you for like at least, there are words at least or at most, and there is a finite number that, see over here, it's at least 25 and 100 is also finite. So it's not greater than, so too much greater than like infinite. You know the maximum value that 100 trees are there right now. Okay, so in this particular condition, you can approximate your normal distribution to your binomial distribution. Okay, so in such case where at least or at most words like this are written, you change your normal distribution to your binomial distribution. I'll tell you one more thing over here, which is like not in like the syllabus, but I really want to tell you. It will improve your knowledge about 1 minute. Some space. Yeah. It will increase your knowledge about when you can actually approximate your normal distribution to your binomial distribution. There is a condition. This is the condition. When your n multiplied by p is greater than 5. In this particular question, your n is 100, right? And your p is 0.191. So 100 multiplied by 0.191. We calculated in last part that this is actually equals to 19.1. So 19.1 is greater than 5, right? The second condition which should be satisfied is NQ should be greater than 5. What is my Q? Q is basically my 1 minus P. Okay. So 100, 1 minus 0.191. It's 100 multiplied by 1 minus, it is 80.9, right? So 80.9 is also greater than 5. So my both conditions are satisfied. I can approximate my binomial distribution, my normal distribution to my binomial distribution. Okay. For SL, this much is enough to know, I think. Okay. So I will approximate it to binomial distribution because it has some finite values now. Okay. So your probability of x is greater than 25. Okay. This is the condition now. Now on your calculators, go to distributions and go to binomial distribution this time, not normal distribution. Okay. We'll go to binomial distribution this time because in our question we have at least. Okay. So I will use binomial CDF. Why CDF? Because I'm using a greater, I have a greater or less than sign. It's not an equal sign. The sign actually is greater than. Okay. So I will use my CDF. Yes. So total number of trials is given n, which is 100. Trials is basically n. Okay. P is the probability, which is 0.191. Okay. Then the x value is 25. So the probability is equals to 0.944. Why I am writing probability of x less than 25? Why I am writing like this? It was greater than equals at least. Okay, at least it was. So I will write 24. So in the calculator, you have to change it to, okay, let me explain why I've done this. Okay, in the question, it was find the probability that at least 25 of these trees are joined. So in at least, it's not x greater than 25. It is x greater than or equals to 25. So x greater than equals to 25. As we know that our calculator, it actually calculates only the values less than. It will calculate the value of probability of x less than equals to 24. Okay, it cannot calculate greater than sign, the binomial distribution only. The normal can, but binomial cannot. So what we say that we calculate the less than and we change it like this. Probability of x greater than equals to 25 is actually equals to 1 minus probability of x less than equals to 24. One more time, I'll repeat it for you. Find the probability that at least 25 of these trees are giants. Okay? At least actually means that 25 is also included. So if I'm included x greater than equals to 25, my calculator is not allowing me to calculate the binomial distribution while using this greater than sign. Rather, it uses less than sign, or you can say that the general formula is your probability of x greater than equals to a is actually equals to 1 minus probability of x less than a. Okay. So okay. Now I've just calculated this value, probability of x greater than less than equals to 24 from calculator. Let's do it. Where I was here. Go to the distributions. Okay. Go to the binomial CDF. Okay. Number of trials is 100. Probability is 0.191, but it's 24. Now calculate the value. It's probability of x less than equals to 24 is equals to 0.9122. Okay. Okay. Now I can calculate the probability of x greater than equals to 25, which is 1 minus 0.9122, which is equals to 0.086. Finishes our question.